Hello. Today we are going to do homework 5 and we will start with exercise 1. And we will frequently use following rules, so I will just write these rules up first. So that's a kind of intro. We will frequently use following rules. 1. The expectation of ax plus by plus c is equal a expectation of x plus b expectation of y plus c. So the expectation of a number, constant c, is just c. So then 2, the expectation of x times y, I could write here, is equal the expectation of x times expectation of y if x and y independent. Random variables. 3, the definition of a variance, or we call it the rule here. The variance of x is the expectation of x minus the expectation of x in the power of 2. And this can be rewritten as, and we will show this in exercise 1a, as the expectation of x in the power of 2 minus the expectation of x in the power of 2. And lastly, 4, the covariance of x comma y is equal the expectation of x minus the expectation of x, like this, times y minus the expectation of y, like this. Remark. Remember that an expectation is just a number in example not a random variable. So how can we interpret this? For example, the expectation of x, we could interpret that as mu, which is just a number, normally the population mean. Okay, so this is just something I will use in the exercise 1 now. Exercise 1a, show that variance of x is equal the expectation of x in the power of 2 minus the expectation of x in the power of 2. Okay, then we have to use the rule. Rule 3 above So the variance of x is equal to the expectation of x minus the expectation of x in the power of 2. Okay? Then I'm just expanding the square such that inside the brackets here, I can see I have a square, so that will be x in the power of 2 minus 2 times x times the expectation of x plus the expectation of x in the power of 2. And then I let the expectation go into the brackets here. So I get expectation of x in the power of 2 minus the expectation of 2x, the expectation of x, plus the expectation of x in the power of 2. This first one is perfect because we can see that it's what we need from what we are going to show. And this next one, here we have to remember, we can put 2 outside the expectation, just following rule 1 here. We take the constants outside the expectation, a outside like this. So, but also the expectation of x, also this one is an constant, is a constant. So I can put this also outside the expectation, such that in the way we have defined it here. So 2 times the expectation of x, the expectation of x. So that's the 2, that's this one, and it remains the expectation of x. Plus, and since the expectation of x is a constant, the expectation of x in the power of 2 is a constant, so I can put this outside the expectation, but or just thinking that the expectation of this constant is the constant, using the fact that the expectation of a constant is just c, or a constant. So nothing special about this, so therefore this is the expectation of x in the power of 2. And then we have minus 2 expectation of x in the power of 2 plus expectation of x in the power of 2, and we get expectation of x in the power of 2 minus the expectation of x in the power of 2, like this. And we showed what we was asked to show. Okay, B. For some constant a, show that the variance of ax is equal a in the power of 2 variance of x. Okay, then we have to start with the formula, the variance of ax, and I use the formula which says that this variance is the expectation of the x, but the x is now ax, minus the expectation of x, which now is ax, in the power of 2. And so I have to manipulate this as I did with the last expression above, almost the same way. So this gets the expectation of well, we don't do it the same way. Here I first do some factorizing. I see that I can put this a outside the expectation, like this. And then I see I can write this as it's many ways to do it, but I think I do it like this. So a parenthesis x minus the expectation of x in the power of 2. And then remember that ab in the power of 2, that's equals a in the power of 2, b in the power of 2. So here a is a and b is x minus expectation of x. So this is actually just the same as the expectation of a in the power of 2 times x minus the expectation of x in the power of 2. And then we know that a in the power of 2 is a constant, so I can put it outside the expectation. Like this. And then we see that this is nothing else but the variance of x that we know from the last exercise. So above in exercise 1a we have this connection. So this is then, or from the rule above. So this is a in the power of 2 variance of x. So we got what we was asked to show. C. Here we are going to take and show that the variance of a plus x is equal the variance of x. So how are we going to do that? We use the same procedure as last time in exercise 1a and 1b. So the variance to something is just the expectation to this something, a plus x, minus the expectation to this something, a plus x, in the power of 2. Just following the rule. So then we get a plus x minus the expectation of a, I think this is very easy now, minus the expectation of x, following rule 1, in the power of 2, and then we get the expectation of a plus x minus the expectation of a is a minus expectation of x in the power of 2. And this is nothing else but the expectation of, because a cancels out a, so we get just x minus the expectation of x in the power of 2. And this is just the variance of x. So everything okay. D. Show that the covariance show that the covariance of x comma y is equal to the expectation of x minus the expectation of x times y minus the expectation of y. Like this. So we have to show this. No, that's the definition. So we have to go through that one. So we shall show that this is the same as the expectation of xy minus the expectation of x times the expectation of y. So that's what we are going to show. But to show that, we have to use the rule from above, and then I use the rule 4 here. So then I know that this can be written as the expectation of x minus the expectation of x times y minus the expectation of y. Like this. So then I just multiply these parentheses out, and I get nothing else but x times y is xy, minus x times expectation of y is x expectation of y, and then I get minus expectation of x times y, and then plus expectation of x times expectation of y. And then we see, then I'll put the expectation inside the parenthesis here. So I get expectation of xy minus expectation of x expectation of y minus expectation of x times y plus expectation of x times expectation of y, like this. But remember that the expectation of, remember this remark, which I use all the time here. Remember that an expectation is just a number, in example, not a random variable. So, and then we know if it's just a number, or let's say a constant, we can put it outside the expectation. So here, now we may probably understand it. Here, the expectation of y, this one, is actually to seen as a constant. So I can put it outside the expectation. So then I get expectation of y outside this big expectation, and then I got x left, like this. Minus, and here I can put expectation of x outside the expectation, and that is left with y, plus, and here I can, here is, we just have the expectation of a constant, because the expectation of x is a constant, expectation of y is a constant, and a constant times a constant is a constant, and the expectation of this constant is a constant. So I get this as expectation of x times expectation of y. And then I get this to be expectation of xy, and then I have minus expectation of y, expectation of x, minus 2 of them, plus 1 is minus expectation of x times expectation of y. And we got what we was asked to show. Then we can take E, and we are asked to verify that or show that if x and y are independent, then the covariance of x, y is equal 0. Show covariance x, y equals 0 when x, y are independent. Okay? We know from rule 4, let's see in the top here. No, not rule 4. Rule 2. We see that if x and y is independent, the expectation of x times y is the same as expectation of x times expectation of y. So we know from rule 2 that when x, y is independent, the expectation of xy is equal to the expectation of x times the expectation of y. So this implies that the covariance of x, y, which we know is equal to the expectation of xy minus the expectation of x times the expectation of y, must be equal expectation of x times expectation of y minus the expectation of x times expectation of y. And then we see that this is 0. So, perfect. The last exercise in exercise 1. F. What are we going to do here? Here we are going to show that the variance of ax plus by is equal a in the power of 2 variance of x plus b in the power of 2 variance of y plus 2ab covariance x, y. So we will show this connection. A, b constants. If you doubted it. Okay, we have to go the hard way. We're going through, as we have did many times this exercise, we're going through rule 3 here. So then we know that the variance of ax plus by, that's equal the expectation of this something we take variance of, which is ax plus by minus the expectation of this something which is ax plus by, and then everything in the power of 2, like this. And then we have to manipulate a little bit, but first I can take this inner expectation and fix that one. So we get ax plus by minus, and now I'm a little faster, so I get a expectation of x minus b expectation of y, and everything here in the power of 2, like this. And then we have to be a little smart here. We have to write this as, we can write this as just rearranging here. So I get ax minus a expectation of x plus by minus b expectation of y. And then I do like this. I think of this as one thing and this as another thing, and then I can look at this as a square, which the first green parenthesis could be looked at as a, and the last one as b, and then I have a plus b in the power of 2, and then we can expand the square. So I'm now expanding the square, but my old a is now ax minus a expectation of x, so I get following ax minus a expectation of x in the power of 2 plus 2 times ax minus a, oops, minus a expectation of x times by minus the expectation of b expectation of y, parenthesis, and in the end plus by minus b expectation of y in the power of 2, like this. And then we can do a little more here. I could write this as okay, I just let the expectation go into the parentheses here now. So I get the expectation of ax minus a expectation of x in the power of 2 plus the expectation of 2, and I factorize out here now in the same time a in the first parenthesis and b in the second parenthesis. So I get this. Be sure you understand what I'm doing now. And in the end, plus the expectation of by minus b expectation of y in the power of 2, like this. And then we recognize this from last time, but I take it slow anyway, so I can write this as a in the power of 2, I take it a little faster than last time, x minus expectation of x in the power of 2 plus 2ab, which is a constant outside the expectation, x minus expectation of x, y minus expectation of y, plus the expectation of b in the power of 2 times y minus the expectation of y in the power of 2, like this. So then we have a new constant in this first bracket here, a in the power of 2. I can put outside the expectation. So I get a in the power of 2, expectation of x minus the expectation of x in the power of 2 plus 2ab. And now I see that this this part here, this is just the covariance of xy. So this is the covariance of x comma y. And then plus b in the power of 2, expectation of y minus expectation of y in the power of 2. And then we see that this first expression, this one, this is nothing else but the variance of x, which we have showed earlier, or we know from the rules, and plus 2ab covariance of x, comma y, and then this one, which also is nothing else but the variance of y. So we could write this as the variance of y. And this was what we was going to show. So everything's perfect, but we could write everything in black. So the result is a in the power of 2 variance of x plus 2ab covariance of x comma y plus b in the power of 2 variance of y. Okay, everything nice. So then it's exercise 2, and we take that in next video.